We are going to continue with log functions and their graphs. So let's look at y equals 5 raised to the x. The inverse is going to be y equals log base 5 of x. If we have y equals 8 to the x, the inverse is going to be y equals log base 8 to the x. Okay, we need to look at some properties. So y equals log a to the x equals a to the y. Okay, so what this means is, remember how inverses, we switch the x and the y, and that's how we're able to come up with the inverse function? So it's the same thing here. So if I have 2 equals log 3 base 3 of 9, that's the same thing as saying 3 squared equals 9. So I'm going to show you how that comes about. So I like to write it the other way. Let's do the log first. Okay, equals. So what it means is 3 squared equals 9. So we're going to do a swirl. 3 squared equals 9. So 3 squared equals 9. So we're going to call this the swirl. All right, the other one, it's already written in the right order with log first. Log 5, swirl. So 5 raised to the 3 equals 125, which that is true. So write the log functions in exponential form. So we're going to do the swirl. 3 squared equals 36, or 6 squared equals 36. Okay, the next one. 7 to the negative 2 equals 1 over 49. And that is true. The reason that's true is because 7 squared, but with a negative 2, is 1 over 7 squared, which equals 1 over 49, using the property of exponents. Okay, next one, do the swirl. 32, swirl it around. So 32 raised to the 2 over 5 equals 4. So we could try that out in our calculator. Okay, the next one, 2 half square root. 2 to the 1/2 equals square root of 2, which that is true. If I take the square root of x, that's the same thing as saying x to the 1/2. If I take the cube root of x, that's the same thing as saying x to the 1/3. Okay, write the exponential equations in log form. Okay, so we would swirl it around, and we always end up here, right? So that is our equals. So it's log base 31, 3. Log, or 81. Base 81 of 3 equals 1/4. So if we were to swirl it around, it's 81 to the 1/4 equals 3, which is exactly what we were supposed to convert. So our answer, where it says equals whatever, that's going to be our exponent. This is our base. This is what the log is. So log base 81 of 3. Okay, the next one. This is our answer. So equals 1 over 36. No. Let me back that up. Our answer is this, the exponent. So equals negative 2. So it's going to be log base 6 of 1 over 36. Okay, next one. So our answer is the exponent, so equals a. So log base g 4 equals a. Okay, this can be our answer, so equals 4. So log base 2 of 16 equals 4. Okay, so we can convert between log and exponential. So here are some properties. Log a1 equals 0, because if we do the swirl, a to the 0 equals 1, which that's an exponent rule. Anything to the 0 power equals 1. Okay, swirl it around. A to the first power equals a. So if these are the same, then it equals 1. If it equals 0, then this is 1. Okay. Log base a, ax equals a to the log a, x equals x. See how it's kind of the same thing? So they're kind of canceling each other out. This is canceling this. This and this are canceling. So it equals x. Then our last one, log base a of x equals log base a of x, then x equals y. If they have the same log and base, then you're able to simplify those out and you just get x equals y. Okay, let's look. It says evaluate with a calculator if possible, then confirm using the calculator. I'll teach you in class how to confirm this. All right. So log base 4 of 4, we're going to say equals x, so that way we can do the swirl. 4 raised to the x equals 4. So x equals 1. I'm just going to put 1 instead of x equals. Okay, number 2 equals, I'm going to just say x, 5x equals 5x. 5 raised to the x equals 5 raised to the x. So what is that going to be? 1. Okay, let's go to the next one. Log base 7 and 7 are canceling each other out, and that just equals 14. We're going to say log base 6 of 1 equals x. So do the swirl. 6 raised to the x equals 1. Okay, next one. Let's say equals x. I'm going to swirl it. So 5 raised to the x equals 1 over 125. So I've got to figure out what x is going to be. So if it's a denominator, then I know it's got to be a negative. But let's figure out 5 to the what power gets us 125? And that is 5 to the third power. Then I'm going to bring it up top using exponent rules, so it's a negative 3. So this is negative 3. Okay, let's look at the next one. Equals x, swirl. So 10 raised to the x equals 10,000. So that is 1, 2, 3, 4. Is that right? 10 to the 4. 1, 2, 3, 4. 10 raised to the 4th power because we got 4 zeros. So we have 4 is our answer. Okay, next one equals x. 4 raised to the x, 2. 4 raised to the x equals 2. So that I need to change this. I didn't actually get my answer. I don't know why I wrote it there. But 2 raised to the 2 is 4, and then raised to the x equals 2. So what this is going to have to be is 2 to the half to get to the first, right? So it's like 2x equals 1. So x is 1/2 is my answer. Okay, let's go to the next one. Equals x, swirl it. 10 raised to the x equals 1 over 100. Well, this is kind of like the other one I had to reduce. So 1 over 10 squared, which would end up being 10 to the negative 2. So the value is negative 2. All right, that is all we are going to do on this video.